when you think about Oregon, Port of Portland being a fairly middle-sized port, we get ships from 64 countries, and that's a lot in three oceans, 6 continents. That's very international. And nowadays, ships can transit the Pacific Ocean in 7 days or less. In the Columbia River Basin, we have one new invasive species appearing every 5 months. So that is a period concern, and people don't know that they're moving invasive species.
There are a lot of things that have been introduced, and you have to sort of distinguish. Introduced means it's exotic, it doesn't belong here. Invasive means not only does it not belong here, it's having an impact.
The dock that broke off of Misawa, Japan actually went through about a 15-month journey. And so it was very surprising to us that we actually had a community of organisms. And the latest count is that there's 102 different species on that dock. And virtually all of them were alive when they came. So that gives you an idea of basically how organisms move around, how connected our continents are by people.
Ships will go to their home port and offload whatever they're bringing in, and then they'll refill the bilge or the ballast tanks of the ship with local water, say from Tokyo Bay, and then they'll come back over to pick up, say, chips in Coos Bay, and on their way back they will come into port and empty their ballast water at dock. So Tokyo Bay water would be introduced into Coos Bay water, and if you have a ship transporting the ocean in a matter of days, the organisms in the ballast water are still alive, and so they get introduced into a foreign estuary, and those are potentially ones who could live and settle and reproduce.
Oregon has a list of plants and animals that are deemed to be the 100 worst invasive species that we do not want in the state. And one of those species is an animal called it's a colonial tunicate, and it's called Didenum vexillum. Actually is a matrix of thousands, tens of thousands, millions of individual animals that are cemented together by this tunica cellulose-like material.
In the case of this Didenum, this ascidian, this tunicate, it's like a sheet of living tissue. Be, I guess, analogous to some sort of lichen or something like that on a tree, right? And the bivalves, the oysters or the mussels, have to have access to water, pump it in and out through their gills. So they have a gape in the shell, and they pump water with the cilia that are on their gills, and they actually take food particles out of the water with their gills. And so if you have a sheet that's sort of overgrowing the shell, it can actually occlude the gate, close the gate, and restrict water flow, and essentially smother the animal so that it can't feed and it can't get oxygen in the water, and consequently the animals, the bivalves die. It kills them. Now, if people were more aware and they made efforts to clean their boat hulls, and if they certainly when they pull their boats would wash them with fresh water, and we would need to make sure that the wash water didn't go right back into the marinas and so forth, there could be the potential of reducing the spread. But once taxa get introduced to a particular area, if they are rapid growing and capable of both short scale and long scale dispersal, it's a biological nightmare. It's like controlling a disease in terms of the effort that it takes to eradicate things, and it's just not that high on people's radar.